Hello everyone, welcome back to Coding Badly. I'm so ready to go. My code is already on the screen and I haven't even started. Hello, welcome to Battlesnake. If you are new in these parts, Battlesnake is a multiplayer programming game where you write the AI, the logic, the code to control a snake in a multiplayer battleground and hopefully come away victorious against other snakes written by other talented coders. Today we are here to watch Coding Badly. Coding Badly is a Battlesnake stream where we do things with Battlesnake that shouldn't arguably be done. That includes writing Battlesnakes in weird languages, which we're doing today. It includes doing weird hacky ways to control snakes, like facial recognition. It includes messing with the game in other weird ways, like building in Blockly and this kind of stuff. But today we are continuing with a snake we've been building for the last couple of sessions, and that is a snake written in the programming language Factor. So we'll bring that on in a moment. We're also going to be looking at another Factor snake today. Anyone who's tuned in for the last two sessions will know that I've had some very welcome help in the chat from someone from the Battlesnake Discord. I assume that's how they found out about the stream. I have no idea how they found out about the stream, actually. So I've had a lot of help in the chat from someone who knows Factor and does write Factor. I did not know Factor 3 weeks ago. And they actually beat me to the punch. I've been writing a Factor snake here on stream, and they actually got their snake onto the Battlesnake platform and running and in games before I did, and they sent me the code today. So we're going to be having a look at the code, because it's very different to the Factor that I've been writing, and it had a lot of tricks I hadn't seen before, so we're going to try and understand those. And I actually can't read this code, I'll be honest with you. I can't read my own Factor code, but there's some stuff that, like, just some ways to write Factor I haven't seen, and that's always really fascinating to me. I think one of the things I always have when I come to new programming languages is like, okay, I've understood the syntax and I'm writing that code, but am I writing it idiomatically? Am I writing it like someone who actually codes in this language every day would write it? And that's been one of the things that's been really interesting with Factor, because of the paradigm of the language. But let's explain the paradigm of the language first for folks who are new, this is their first time tuning in for this series. Let's explain what Factor is so that this makes some sense. Nope, hang on. Trying to get that monitor where I want it to be. Okay. Ba-boom. All right. Let's go over to Factor. Let's go look at Factor. So Factor is a concatenative stack-based programming language. Some big things about Factor that make it really unique. So stack-based is the big one. You pass data around via a stack. There's just one big global stack data structure. Functions aren't passed parameters in the typical way. They get their parameters by taking them off the stack, and they produce their results by putting them back on the stack. So that's a really huge thing. And a stack, last in, first out, the ordering is important, and so that's a big thing you're contending with when you're building functions that are consuming data that you've written to the stack in the past. The concatenative aspect, I'll be honest, I'm going to explain that really poorly, but this is to do with the way you actually write and compose functions and code. So not all concatenative languages are postfix, but Factor is postfix, which means that the arguments precede the function, and that's also, I think, in Factor's case, to do with the fact that stuff is going on the stack. But yeah, it is very different. So if I were to just open the listener, so this is Factor's little REPL doodad. Let's quickly do we won't spend too much time on this because I imagine folks who are tuning in at this point have been here for a while, and I don't want to waste those time going over the basics again. There we go. Cool. Okay. So, yep. I've just put a 1 on the stack. You see there it prints out to the stack. I put a 2 on the stack. I then do plus. That's a word, Factor's name for a function, and plus consumes 2 items off the stack, adds them together, and puts the result back on the stack. So there we have 3 on the stack. So that's the basics. That's where the stack comes in. We can drop things off that stack. We have a bunch of words for manipulating the stack. For example, I can do 1 and 2, and then I can swap them, and then we have 2 and 1, which is very useful if you wanted to do subtraction, where the order of operands does matter. What else is important? We have anonymous functions, anonymous words with square brackets. So Fine, we'll do a boolean. Anonymous functions with square brackets, and then they go on the stack and could be executed and used by other functions. So, for example, I could just do, I could do a bunch of these. So there we've got a boolean statement, so is 1 equal to 2, and then we have two expressions, 1, 2 plus, and 2, 1 minus, and then if I give those to if, you'll see we get 3, because what if does is it takes a bunch of quotations, it takes an anonymous function that produces a boolean, it takes an anonymous function that that will get run if it's true, and it takes an anonymous function that will get run if the boolean is false, and so we end up with, I think I've got that wrong way around. I think it's false first and then true. It must be in this case because 1 and 2 are not equal. So then we end up with 3. So that's Factor. It's a quick look at Factor. This thing I'm in is the listener. It's the kind of IDE-like environment. It's delightful. It has built-in help. It has all kinds of tricks up its sleeves. It allows us to inspect objects in a really nice way. We've got built-in docs over here, and I'm going to shove this off to the side. And then we have our Factor Snake, which actually is coming along quite nicely. That's actually a little bit out of proportion. Let's adjust that just a tad. How's that looking, chat? I don't know if anyone's in chat. How are we looking? I've chosen a terrible day to do this because it's October and November. Well, now it's November, but you know, it's peak conference season. And in particular, the company that I work for on my day job, it's their conference season. And I'm currently competing with the CEO's technical demo. So I don't know if anyone's here. I might just be talking to myself and I'll have a great time. One sec. But that's okay. We've got the Platinum tournament later on today. So in a couple of hours, the Snakes in the Platinum bracket of the Full League we'll be seeing who wins the Platinum bracket, which will be very exciting. Hey, we've got hey Sonia, and Real Canadian Cheddar. Conflict of interest. Yes, exactly. I'm conflict of interesting myself. Appreciate the support, Sonia. Okay, all right. First thing I need to do actually is this prove that the snake I wrote works. I will say that. I did do some work outside of stream. So this snake works, but that's because I was at a hack day over the weekend and spent a little bit of extra time on it, which was extremely fun, and I'm really glad I did. I had a wonderful hack day. So let's get that up. Let's go back to my browser. Let's go over to Battlesnake. Let's do my login. I'll log in over here. So what our snake currently does, and we'll go through the logic in a moment, but our snake is essentially the same as one of the starter snakes. So if you were to go to the docs and you were to grab a starter snake, those snakes are set up by default to do what we call a random safe walk. So they do the bare minimum to check that a cell next to them isn't currently dangerous, by which I mean it isn't occupied by another snake, or it isn't out of bounds, and they check all of the cells around them, and then they keep the ones that are safe, and then they pick one randomly. They don't do any look ahead, they don't look, they only check the cell next to them at the present time, so a snake could move into a cell and cause them problems. They don't have any logic to further refine the list. Once they've got a list of safe cells based on bounds and based on snake bodies, that's it. They don't do any food logic or anything like that. So that's kind of where we're at. So let's edit the Factor Snake. Let's throw in my new ngrok URL. Let's save that and let's run the snake. So we need to use snake, and then we do. I actually gave it a main. Snake, because I was messing with deploying it. So I think I just want start server. Oh no, wait, yeah. So start server. Okay, we should be up. Let's have a look. We are up. Okay. So let's create a game with Factor Snake. Custom game. Oh no. Presumably that's because I need to refresh. Refresh. Unable to load metadata. Oh. Oh no. Oh no, I know what's happening here. Why is that needs to be a string. There we go. So one thing I did change between this code and the previous code. I used to have the snake info. Hey Brad, welcome to the factor nightmare. So I used to have the snake info here as, I actually think I still have the original version. Yeah, there we go. I used to have the snake info here as like escaped JSON because I didn't understand how factors JSON support worked. So I was just like, I'll do escape JSON. I'll do like some escaped JSON here as a string, and then give it to the factor reader, the JSON parser. And that was so that I could give it to the. So let me close all this rubbish. That was so I could give it to this JSON content builder. It didn't occur to me at the time that what this does is converts it into a factor hash table. So I went back this morning and actually rewrote our info as a factor hash table, rather than it being a horrible escaped JSON string. So we can now this reload. One quirk of the development environment that I still haven't solved is after running my snake, the HTTP server does have live reloading, but only for like code that gets executed, I guess, like within the scope of the HTTP server. That's not accurate. I'm just guessing. So in the case of these like root handlers, they get whatever happens to them, they get evaluated and then passed to the HTTP server. So if you change the root handlers once the server is running, they don't the HTTP live reload doesn't seem to kick in, so then I have to restart the whole factor listener to restart the server. But now this should hopefully work. The problem there was that I'd put in the API version as 1, the number, not the string, and now we've got factor snake. So let's go create the game. We now have our game. Factor snake, start game. And we will see that our beautiful, beautiful snake doth work. Look at it. It works. I'm so happy. The snake in a programming language that I've been writing for a grand total of 6 hours on stream is now officially better than my Haskell snake, which I spent 3 years studying at university. So there we go. Progress. We are moving along. So, oh, that's terrible news. What are we going to do today then? The snake works. What do we do? Well, as you can see, the snake is stupid. Actually, why did that happen? Oh, it got itself into a corner. As you can see, the snake is bad. So we will continue working on the snake, and we're going to add some more logic to it. But as I mentioned at the start of the stream, we also got sent some code from a real factor developer who has been helping us out in the chat the last couple of streams. This chat, I'm just going to go ahead and say it. This chat nerd sniped them, I think, where they were like, "Oh, look at this guy not knowing how to write factor. Let me have a go," and went and wrote some a really cool min-max snake. So we'll have a look at their. Good Acre Liam says now to generate the factor from a Haskell EDSL rate. I actually think that wouldn't be terrible, because like a lot of like it's already pretty easy to write factor fairly Haskell-ish, and I mean, it's at least the way I write factor. It's a good segue into reading my code. At least the way I've been writing it has been very small, essentially single little one-liners that are mostly pure. Take something in, take something off stack, put something back in the stack. So like, it'd be a very one-to-one mapping, and then you're just dealing with like, you need to write some kind of Haskell VM that imagines the stack. But yeah. Okay, so let's look at what our snake is doing. Let's go. We won't explain the web server again. Go watch the first 2 videos. We've spent too long on the web server. Let's start in handle move. So handle move is where the magic happens. So we take in a big blob of game state as JSON, and then we return a move. You can see us constructing this move here. So we take the move as a key, we build a hash map, and then we set move. We set move as the key with the results of all of this stuff. So check surroundings is where most of our logic is. If we go and have a look at check surroundings, again, we're taking game state. The way I ended up building this is a lot of the functions take in a whole game state. This is probably going to bite me at some point. I've got a feeling this is going to end up being slow, but I didn't want to deal too much with working out. So Factor does, this is right back to the beginning. I was talking about the fun of doing languages you don't know is working out what's idiomatic and not. So Factor being a stack-based language, I've been trying really hard to make sure that I use the stack. It does have variables, and in particular, I found this really cool lexically scoped function definition we'll look at in a moment. But I've been trying to avoid them and use the stack. And there's lots of words. I showed you swap. There's lots of ways to manipulate the stack that are really cool. Here's one right here, pick. Pick is a really cool little thing, which let's load up the docs for pick. So with pick, here we go. So with pick, you have X, Y, Z on the stack. So you've got 3 things on the stack, and what it does is it goes and gets the thing right at the bottom, so the third thing, and puts it on top. And then there's also over, which gets the second thing and puts it on top. So I've been trying to do everything stack-based as much as possible because I feel like that's what the language wants me to do. But that's also quite scary, so I haven't wanted to... so just to soften that blow, I've been assuming every function is going to get a complete game state object and dealing with it from there. So how surroundings works is we then get surroundings. So this is just a word which builds the surrounding squares. So we get the coordinates for our snake head, and then we do some things which I'm sure are crimes. I don't know if this is good. Okay, we do a toCleave. Let's start with the toCleave. What toCleave does is it takes 2 items, 2 objects, and then a sequence, so an array, for example, and it applies the x and y to... Nope, sorry, I'm reading the wrong function. What toCleave does is it takes 2 objects and then an array of quotations. So quotations are anonymous functions. So an array of quotations, and then it applies each of the anonymous functions in the array to the 2 objects in turn. So snakehead will produce an x and a y coordinate, and then to the x and y coordinate, each of these anonymous functions is going to be run. So we will be left with an array of 4 things? 4 things. Some things. Yeah, 4 things. We'll be left with an array of 4 things. So basically each of these functions gets given x and y, and the results get left in this array. So this is us constructing the surrounding points in our grid. So basically what we're doing here is we're taking x minus 1, x plus 1, y plus 1, y minus 1. Make coord is uses this cool lexical thing I was talking about. So I was having a real trouble constructing a hash map for coordinates, because say you've got x and y on the stack, and then you're trying to construct like a coordinate using this syntax. So this is the way that you construct a hash map using the stack. So you push your key on the stack, you push your hash map on the stack, and then you you push your value on the stack, you push your key on the stack, you push your hash map on the stack, and then you call set@. And set@, takes a value, takes a key, and then the hash map, and sets the value to that key in the hash map. And so when you've got multiple values and multiple keys, it was just a nightmare trying to interleave these things. But then I discovered that you can define functions with 2 colons instead of 1 colon. And that makes the the variables in the stack declaration. So this is like a type signature. So everything on the left is what you take off the stack. Everything on the right is what you put in back in. And normally these are just words. They're meaningless. It's not type checking. It's not looking at, it's not inspecting these and checking like, is that an X? Is that a Y? It's just looking at the number of things. But when you do two colons, these become the names for the variables, and you can just use them. So here I'm then constructing a hash map with an X, and assigning my X to it, and with a Y and assigning my Y to it. And so that saved me a lot of aggravation, and it's been really cool. But as you can see, again, because I'm trying to make sure I do everything stack-wise, and I'm not trying to fall back on variables, I've really limited where I've used this. I've just used it for these little constructors, and actually this should probably be a constructor, so it should probably be... let's go to the conventions. Hey VJ, great to see you. It should probably be an implementation detail word used by foo. Oh, that's a cool convention. Yeah, maybe it shouldn't be a constructor because that looks like it's meant to be for a class. But yeah, I'm probably not using the naming convention where I should be. So that's been really nice. So I make these chords here. You see another stack word there, dip. Can I remember what dip does? Oh god, yeah, this is cool. So dip. Oh god, VJ says, not gonna lie, factor makes OCaml look easy. I've never been able to grok OCaml. OCaml to me is like you took all of you take Haskell and you just decide like, hey, all of the elegant bits, make them gangly and lanky. And I'm sure that's very unfair, but that's just like what I look at OCaml and I go cross-eyed. It really messes with me in an unpleasant way. But yeah, I mean, I think factor... the way I've been describing it the last week is like... I like programming games. So I like puzzle games that use code. So the Zachtronics games, right? I like puzzle games that use code because it makes the game feel like programming. I like factor because it makes the programming feel like a game. It's like one of those sliding art puzzle games, when you've got like the picture, but it's made up of sliding pieces. You need to get it into place. Messing with the stack and working out like how to get the things off the stack in the way that I need them and how to put stuff back on is like a sliding puzzle game. It's really pleasing. So yeah, what dip does, dip is so you have something on the stack and you have a quotation, and you don't need the something on the stack, it's just in the way, but you want to run this function. So what it does is it takes X off the stack, runs the anonymous function, lets it do what it's going to do, and then puts X back on. So it's just like, hey, I'm just going to take this thing off the stack and get out of your way where you do what you're going to do. And so here, because this line is being used to build the X coordinate, we don't need Y, so we dip Y so that we can build the X coordinate. Okay, so then we do toCleave. So toCleave takes all of these functions and it gives them X and Y result from here. That then gives us an array of things. It gives us an array of 4 values. It gives us 4 things. Each of these functions pushes something onto the stack, so we end up with 4 things, and then we use for array to turn those into an array. Then we build a new array of directions, left, right, up, and down. And then we zip those together. So here we have an array of coordinates, so all of the coordinates surrounding our snake. Here we have an array of the directions, and then we zip them together, so we end up with a hash map of coordinates assigned to their names. Make sense? And let's see this. What I do need to do, I did do a little bit of tidying up. I need to use snake.utils. Oh, I can't use that listener. I'm running a server. That's not going to work. It needs to be using. So yeah, let's see these code. Let's see these words in action. Oh, I've got an error. The word J. Oh, yep. Sorry, I didn't actually abort. I need to do auto use. There we go. And then we'll do that again. Oh, I should just reload. Is that not going to do it? Yeah, I moved everything to utils and then didn't actually do my import statement in utils. There we go. Let's give that another refresh. We're in. Okay, so let's do a load. Let's do a load test file. Perfect. Where did I do all that typing? No, that's correct. Okay, so this is a little util that I wrote just to load a test file of game state so I can mess around without having to keep restarting the server. So we've got a game state. Let's mess with that game state. So let's do get surroundings. So the game state's on the stack. If I do get surroundings, you see I end up with a hash map where down is the x coordinate, left is the down is a pair of coordinates, left is a pair of coordinates, right is a pair of coordinates, and up is a pair of coordinates. So that's how get surroundings works. Where were we? We were in check surroundings. So once we've got the surroundings, we need to check that the surroundings are safe. And there are two things that we are checking currently. We are checking whether the surroundings are out of bounds of the game board, and we're checking whether the surroundings are contain a snake body. So we're going to do the body segments first. I'm really enjoying explaining this to you, chat, because this is factor code that I wrote like 5 days ago. And I honestly, earnestly, like the minute I walked away from it, I'm like, I'm not going to be able to read that code in 2 days. And so this is a struggle. This is actually like archaeology already. Okay, so straight up, this is an anonymous function. It's an anonymous function that's being given to ASOC filter. So ASOC is the name of the class of data structures that hash tables belong to. So sequences contain arrays, ASOCs contain hash tables. So this is a filter operation for ASOCs. And what are we filtering? We're filtering the list of surroundings that we created, so that hash table of our left, right, up and down coordinates. And we're filtering them based on this anonymous function, which will produce an array of booleans, a list of booleans, and those booleans will be wait, no, sorry, I'm totally lying to you. Each element of the hash table will be run against this function, and then it will true or false if it meets these conditions, and then it'll be filtered. So what does this function do? So first of all, you'll notice there's a pick. What are we picking? So as I told you earlier, pick is where we go to the third thing down on the stack and we bring it to the top. We are getting our game state again. So I said I was doing this thing where all of my functions were being given the whole game state because I didn't want to mess around with passing too much state. I just wanted to pass one state object. So I always have a game state object on the bottom of the stack, and I'm bringing that up to use in all of the other functions like get body segment and like chord in bounds. So get body segments picks the game state, and then it gives we pick the game state and we give it to get body segments. Get body segments, really simple. It just gets all of the body segments that are on the map. So it gets all of the snakes, it gets their body, and then it flattens that array so that we just have one array containing all of the chords that all of the snake segments are at. Once we've got those body segments, we index them. I can't remember what index is. Oh, it's finding. Got it. So index takes a thing and an array that might contain that thing and just tells you the index if it exists. So this is us checking whether any of these surroundings are in this list of body segments. So we get all the body segments and then we see if these chords are in our surroundings. This is us actually doing the check. But we then we reverse that logic for reasons, and then we nip. Nip removes something on the bottom of the stack. So in this case, we get rid of, I think it's the game state we're getting rid of. So you take an X and a Y, and then you get rid of something. So that then goes through all of our cells and determines whether those cells are occupied, and then we filter based on that. And so we're left with all of our moves. Just our hash table just has cells which do not contain a snake body. So after that, we want to check if those cells are out of bounds. So we have a similar setup. We have another anonymous function. This one's just split over more lines because this one fit in one line, this one didn't. And we're doing a very similar operation. So we pick to get our board state. Then we're getting the board width, the board height. This, by the way, when we see we're putting a word in quotes and doing keep. Keep is really cool. So what keep does, the type really messed with me. What keep does is it takes an object and a function which will consume that object and produce something else, and it makes sure that after that function has run, that the object gets put back on the stack. So we are consuming our game state. Board width takes a game state. Board width takes a game state, so it would normally take it off the stack and then consume it. And then with keep, we make sure that it consumes it, uses that game state, but then it gets put back on at the end because we need it for board height as well. So board height then takes it, and then we have coord in bounds. So what coord in bounds does is it takes a coordinate, it takes a width and a height, and it checks whether that coordinate is in the game bounds. So this is a very similar setup to the get surroundings here. We have a bunch of anonymous functions in an array, but this time we're running free or, which free or means it takes 3 things from the stack, gives those things to each of these functions, and then it runs Boolean or across all of the results. Really, it's all these little shorthands for like doing multiples of things are buck wild. So that then checks whether any of the directions that didn't have a body are out of bounds, and then again we filter on that. And so what we're left with by the end of this is a hash table just containing the safe moves by those parameters, and then we choose one at random. Very simple. And then all of this stuff is actually, what is that for? 0 swap nth. Oh, that's me. Okay, yeah. So we choose one at random, but what we're choosing there at random is a hash table entry. So it has a key and a value. So we choose 0 basically. We choose the key, so we get the key out, and then we put the key. We set the key as our move, and we return that as our JSON. Oh, I'm actually worn out, chat. That was actually hard work. The absolute mental acrobatics to remember what some code that I wrote on Saturday did was, quite frankly, yeah, gonna need a break. Okay, so what are we going to do from here? Well, as we just saw, the snake does run, it does do the thing, it does survive. It's not smart. And, you know, at this point, we've played enough Battlesnake now, chat. We know that we know that the big leagues, you need to be doing decision tree algorithms. We need to be doing, we need to be building graphs of game states, and we need to be pruning, and we need to be doing min-max and all that kind of stuff. I don't have that in me now and ever, but especially now, and especially in this language. So we're going to do this like Coding Badly Season 1 with Brad and Joe, where we're just going to incrementally add more checks to this function. We're just going to keep changing how we assess things in the hash table. That's what we're going to do. We're going to add more logic. So we're going to start looking for food. We might... so we'll look for food and we'll prioritize food. How could we do... Maybe we'll do a little bit... Maybe we'll look a little bit further ahead. We'll look for tails. We'll eliminate tails from the check surroundings. Yeah. How does that sound? Is there any logic? Like, what are some conditions that you would like to see built into the snake? So all it does currently is it checks for bounds, and it checks for bodies. What strategies should we build into the snake? What else should we look at? So, you know, we can do things like check the adjacent square. Does it contain a food? Are we over 50 health? Cool, prioritize that square. Are we under 50 health? Prioritize that square. We can do things like, does the adjacent square contain a body segment? Yes. Is that body segment a tail? It's still safe. Is that body segment a tail? What snake does it belong to? Does that snake's head have a food next to it? Okay, it's safe. We can do these kind of things. Any preferences, chat? We also can go take a look at Gifty's factor code. Oh no. Let's actually have a look at Gifty's factor code quickly. Okay, so Gifty... Actually, I think... Will I be able to see Gifty in the leaderboard? Gifty did manage to get that snake into the leaderboard right before it shut, I think. Maybe they didn't. Oh yeah, there it is, Battlesnake. It is in the leaderboard. They actually got quite high up. So this is another factor snake. You can see it's got the tag. We need to add the tag to our snake. It does exist. It's on Oracle Cloud now. This snake is a lot cleverer than we're going to be. And let's bring on over the code. Let's have a look. All right. So here we are on GitHub. They have just the one Battlesnake factor file. Their code's a lot shorter than mine. Mine does have a fair few garbage comments in it, but this code is very short. And it's fun. So here they have, this is the definition for the root handler for the info endpoint. So they're doing a very similar thing. They're just not, I define mine, I define my info JSON separately, and then in like a separate function, and then give it to the endpoint. They're doing it all in one, which is nice. They've to find a constant, so I didn't know about this. So these words here, these are parsing words. So these are things you can do to define, this is how variables are defined. You define symbols. And so they're defining a constant, which is, I actually don't know. I guess this is I don't know what this, is this an array? A nested array? I guess it must be a dimension of nested arrays somehow. Yeah, it's not like its own thing. So I guess it is a nested array of some kind, which makes sense. So they have an array of things, and then those things are themselves. So there are 4 items in this. They've just arranged. Why? They've just arranged them all in one line. So 4 items. Each item is the coordinates and the key, which is essentially the same as the hash map. So that makes sense. So if you did move 0, you'd get right. And I imagine the ASOCs. I wonder if the ASOCs stuff, the ASOCs words recognize this as an ASOC. Then do a tuple. So a tuple is a class, essentially. So they're defining a class here. I haven't used tuples yet, but I have. Well, I've seen them. My code does have a tuple definition in it, but it has the tuple definition that's like needed to use the web server, and I don't really know why it's there, but it has it. So yeah, tuples are classes, and they have slots, and the slots are variables, I guess. So we have a class called Snake that has an ID, a length, a health, and a body. That makes a lot of sense. Having a class for, the snake is obvious and good. And then I guess this is the constructor for that tuple, because naming, as said, factor has really strong naming conventions. So these angle brackets mean that this is a constructor. So this will be a constructor for the snake, but I'm going to check that because, again, I haven't seen the syntax. Yes, it's a constructor for a class. So it's C, constructor, class. So that's the constructor function, and then that's the class it's constructing. Very cool. Here we see one of those fancy word definitions that uses lexical scoping. So all of these names here are actually significant. These are variables. So this is for scoring the moves. This is a min-max snake. It does run min-max, and it's doing move scoring on the bunch of possible moves, which is super neat. I don't know how many moves it looks ahead, and then this is beyond my comprehension. This is art. I don't know how to pass it. I don't know how to read it. I can work it, like I've worked out individual pieces of it. I get it. I see what's happening here. But just the construction of it is nothing short of art. It's urban. It looks like a cityscape. Like, you tilt your head and yeah, it's incredible. We'll come back to this. We'll come back to this. So we just learned these round brackets mean like an implementation detail. So like this is just like hiding the horrors of the actual score moves function. Hey, but I don't know how to pronounce your Twitch name in like a one word. So hi, Vudshell, who says, cool to see a unique programming language here. I tried to write a Forth compiler a long time ago. Yeah, for those who don't know, you might have heard of Forth as like a programming language in history. It's very important in the 80s, and it's another stack-based language, and it's like the forebear to Factor in many ways. But Forth is a very simple language, and it's one of the targets for compilers, compiler writing. If you're like learning to write compilers, like writing a Forth compiler is kind of like writing a Lisp interpreter. So yeah, thanks for joining. We are writing our own Factor Snake, but we've been sent code. We've been getting a lot of help from a Factor developer in chat who's been telling me cool tips and tricks, and they wrote their own snake and sent me the code. And so we are the apprentice looking at the master's code and having my mind absolutely detonated. I actually just realized this has syntax highlighting. Does GitHub actually support Factor? Yes, it does. Nice. Okay, we're going to ignore this nonsense for now. Score moves is a lot more readable. It's still weird, but it's readable. To me, anyway. I'm not saying this isn't readable. This is readable. I just haven't spent the time to do it yet. But this is. I think something might have gone wrong. I don't know. These square brackets. The line, the closing bracket being at the start of the line is very chaotic. This construction is really clever, and I really like it. So the way you want to look at this is by looking at the buy and try words. So buy and try are again kind of in that family of functions we were looking at with like toCleave and free or, where they take an object and then they take two functions, two quotations, two anonymous functions, and apply them to that object each in turn. So they produce two outputs. And then try is the same, but with free quotations. So if we look at this top one, we have U of ID. So they're going into the game state and getting the snake, and then getting the ID of the snake. Then they go into the game and they get the rule set, and then they get the settings and they check whether the mode is wrapped. And so here they're doing by, and the two quotations are name equals wrapped, and the is there hazards or not. So is there hazard? So is the hazard damage 0 or something else? And they're applying those two quotations to the rule set produced by this. So what they end up with out of this is knowing whether the rule set has hazards and what strength the hazards are, and knowing whether the game is wrapped or not. Right. But Shell says, my name is unpronounceable, which is why I changed it on Battlesnake to something more comprehensible. Don't know how to change it on Twitch. That's fine. Twitch username changing is difficult, and you can only change your Twitch username like once every 2 years or something absurd. I'm just going to keep calling you Vutshell. Sorry. Okay. So we then have that kind of same construction again here. So here they're getting the board, and then they're looking at width and height, the food and the hazards, and the snakes. So this function I haven't torn apart, so let's get into this. So they're using toOf, which is something that they define themselves, and toOf takes a game state and an A and a B, and it produces a V. So they've got this quotation that says of. So of is how you get something out of an object. So if you've got an object with a property X, you would say, you'd have that object on the stack, and then you'd say X of. Buy curry at. Now that is a lot of stuff. Let's see what buy curry at does. Partially, we've got some curry in. I mean, that was in the name. So you have an object. You have two things on the stack and then a quotation. Partially applies Q to X and Y. So this is a quotation that's expecting an additional argument. Yes, that's what the object is. No. What's the... there's no more stack effect here. So this is a quotation with a stack effect object. And this produces outputs. So a quotation of X and Q. So usually when we talk about currying something, my understanding of that would be we have a function that takes two parameters and you give it one parameter, and what you get back is a function expecting the additional parameter, right? That's my understanding of partial application. And that does appear to be what's happening here. We have an object that's given to a quotation, and what you get back is another function. We have an anonymous function. But the stack effect here indicates that that quotation only takes one thing, and then the quotation we get back puts X on the stack. So I'm going to take its word for it. This is currying, or maybe like I'm just not understanding this. Maybe that like this doesn't preclude there being other stack effects here. But anyway, this produces anonymous quotations. This produces two more quotations that are expecting more arguments, which is the important bit. And then it's a buy, so it's doing it with two objects. So what are the two objects? So this is the quotation. So the two objects can be the A and the B. So you're going to have a JSON game state, and then a thing, and the thing you want to get out, and it's going to buy curry it. So, oh no, sorry, hang on, that's not correct. That's not correct at all. So it will take this A and the B, and it will apply of to it. So of does take two arguments. It takes the object you want to extract data from, and the key you want to extract. So these are presumably the keys. This is what we're extracting it from. I understand. So this produces two of statements which have the keys in and now just need to be given the object, and then by gives both of those partially applied functions the object, and then you wrap them in an array. That's very good. I like that a lot. This is a really cool function. I don't know if Gifty is watching. toOf is great. Get toOf in the standard library. Why is toOf not in the standard library? That's great. toOf should be in here. I've only just grokked that its name is toOf, and now I understand. Cool. So, back to the scoring. So we're toOfing width and height. So we're getting the values for width and height from our game state. And then we're doing a very similar trick here to get the food and the hazards with of and a pos. Pos is something else they define as well. So that's just position. This is shorthand for getting the X and Y using two of a thing. So they're mapping. So they've got this position function which gets the X and Y coordinates for an object. They're then mapping that across all of the food and hazards. So they build a array of all of the food and hazards. That's really nice. That's really tidy. That's a lot. Let's compare that to my horror show. So like where we get our snake bodies. So we do. They're not doing a flatten in there, so I guess they're leaving it nested. So we get the snakes, so that's board of snakes of. So they board of snakes of. Oh, sorry, we're looking at food and hazards. I'm not doing food and hazards. I can't compare this. I'm not doing foods and hazards yet. So let's have a look at their snakes. So they get the snakes. They do care about the ID length and health of the snakes currently, and that's good to see. And then they're getting the bodies. They're doing this position trick again, so mapping position over it. So that's very similar to what I do. Getting my snakes, doing body of map. And then I flatten it. They use it to construct snakes. Oh, that's cool. So they're actually building a representation of each of the snakes with their class. Which I guess makes sense because they're doing, min-max, so they need that data to score, whereas I'm just like getting the body segments and detaching them from reality. So that's really cool. That's really nice. And then we have a try. What is this actually trying? These are the three functions, and they're all getting run on board, which is great. And then this itself, we've got three things. So we've got the function that's getting your snake, or the snake ID, the function that's getting the rule set, the function that's passing the board. So we're trying those three things against the game state that's been passed in, and then giving that to score moves. And this is producing the scores. Why is that producing? Oh, that's because it goes into this horror show. Okay. All right. Let's understand the horror show. So score moves. What does score moves takes? Takes a snake ID, hazard damage, whether the board is wrapped or not. Dim. What is dim? What is dim? Oh, dimensions. Dim is dimensions. Takes the dimensions. It takes the food positions, it takes the hazards, it takes the snakes, and it takes the depth. They're setting the depth to 1, so they're only looking 1 ahead. This is so cool. Like, I understand. I get it. And then they produce the scores. Okay, so we have snakes. So again, this is lexically scoped. So all of these, unlike the other stack effects, so unlike this stack effect, JSON is not a variable. This can't be referenced. It's just shorthand for something being consumed. These are, in this one, because of this double colon, these are variables that can be referenced. So that's important to keep in mind. Snakes. What is snakes? Where is snakes? Oh, snakes is here. We have snakes. Snakes is a variable. So we put snakes on the stack. We've got the variable, snakes is on the stack. So then we've got some anonymous functions, and we've got a map. So this map is presumably applying this function to all of the snakes. So what's in this function? We are changing the health by 1. So this is evaluating the turn. This makes sense. So we're scoring each of the possible moves. And to score the moves, we're going to want to know what the snake's health is next turn. So we change all of the snake's health by 1. Dupe just duplicates the object. This is duplicating the snake, I would assume. We're getting the body. So this is, again, another factor naming convention. This is to access a property. So we're getting the body, and then we're getting the length of that body. That's great. We're getting the length and then subtracting 1. Why? Oh, and then we're checking the minute. Okay, so then we're subtracting length by 1. And then we are getting the minimum. So I guess that's to see, is this our length? This has to presumably be our length. And then we're seeing which one is smaller, I guess. I think that's what's happening there. I'm not sure what length this is referring to. This is an accessor, so this is the length of something. But this is being mapped to a snake, so presumably it's the snake's length. So I don't quite get why we're comparing. But these are both functions that are being bied on something. I don't understand this one. Why would you check all the body segments? So we've got a snake. We're checking the length of its body array and then comparing that to 1 minus the length. Why would we do that? I don't know what that would what purpose that would serve in a min-max. But maybe I'm misunderstanding it. I don't know what this means. What does this? We've got a quotation. Sorry, a literal fried quotation. Place of the fry specifiers. What is this? What? Oh. I see. Okay, cool. That's really cool. Gifty, this is a really neat trick if you're watching. So this is a type of quotation that kind of acts like this lexically scoped thing. So normally a quotation takes things off the stack and we would have to manipulate the stack to get them where we want to go. But instead what this does is it defines, you get to put this slot in the quotation. And so it takes something off the stack and puts it into where you want it to be. So that's really cool. Nice. And then we change body again. Maybe let's go look at this change body function. Maybe that will elucidate what's happening here. Oh. Wait. Where is change body defined? What? Is this something you get for free with an object slot? With a tuple slot? Change? It is. This language, it blows my mind. This is a type of accessor. Okay. I guess if I just search change. Doesn't seem to be it. Let's go to accessors. Why won't this load? There we go. That's a lot of accessors. That would be why it didn't load. Yep, that's not useful. So yeah, it's just gonna be change. These are fine. So I guess it just applies. It's taking. So change body is an accessor for this slot. So there's a slot on the tuple, on the snake tuple called body. Change takes a quotation, applies it to the item in that body, in that slot, and then puts the result back in. Neato. We like it. Okay. So I'm following so far. This cityscape of functions is making sense to me. Learning a little bit about minmap as well. So we do that to all the snakes, and that will produce. What will this produce? This will produce. a snake. This will produce an array of snakes which has their health reduced by 1 and has had their I still don't get what this is doing. Let's check out actually know what min is. So the smallest of the two. So we then get the smaller of these two, whether it's the body length or the length minus 1. And then we pass that into the head. I'm assuming there that head is a function. So this is getting... So we're getting the smaller length, whether it's the number of segments in the body or the length that actually belongs to the snake class. And then we're getting the... this is getting the whole body minus the tail. This is getting the body minus the tail. Okay, so we're looking at the number of the elements in the snake body array, and then we're looking at the snake length, minus it by 1, taking the smaller one, and then heading that. So we're only getting those many elements, but minus 1 is usually going to be the smaller one. So you're getting the first length minus 1 elements, and then we're changing the body. So we're cutting... we're cutting the tail out of the snake array. That's great. That's super cool. General Error says, I have to drop off for dinner. Have fun. It's the Platinum Tournament final in this channel or the Twilio channel. It is in the Twilio channel. The Platinum final is in 2 hours over on twitch.tv/Twilio. I believe we'll be hosting it from this channel though. So if you do end up in this channel by mistake, you will still be able to watch. You'll just be in the wrong chat. But yeah, join us in the Twilio channel for the Platinum final in about 2 hours. Oh, awesome! That's Word Shell. I also like your new avatar. That's very cool. And yeah, enjoy dinner. Thank you for dropping by. Okay, so let's just recap some things we've learned here. Again, Gifty's given me the gift of factor through their code. Tuples get these change accessors, which lets us give which are just generated for the slots on the tuple. And they take a quotation and they do an in-place change of the slot on the object. And then we have these fried, which is a wild name, fried quotations, which basically allow us to place the thing we consume from the stack wherever we want. So it's kind of like an anonymous function where you want lexically scoped variables but don't want to name them, or can't name them rather, but you still want to be precise in where you use them, which is really cool. Okay, we understand what this is doing. This is producing an array of snakes, which has had their health changed by 1, and they've had their tails cut off. Super cool. Super cool. Next up, we are then going to be manipulating that array. Do y'all read code you don't understand often? If I'd really recommend it. There's a group called the Code Reading Club. Which is partly out of a research, a CS researcher called Felina here in the Netherlands, who does a lot on how the cognitive processes involved in programming. It's just a really good book. Bear with me. Wrote this, The Programmer's Brain. Would highly recommend it. It's what every programmer needs to know about cognition. And yeah, one of the things she's part of is this code reading club. I think it's actually organised by one of her research students. And it is exactly what it sounds like. It's, examining the practice of code reading, intentionally reading code, as a way of improving your coding efficacy, I think it's really cool. I find it a really useful exercise, and I'm finding it very enjoyable right now. And I don't think we do enough code reading. Okay, let's continue. So, our array of modified snakes. What are we doing here? Oh god, there's a lot of quotations here. Where do we start? Okay, let's see what's at the end of this. Does this really go all the way to the bottom? I don't know where this ends. It's got to be here. This has got this has got to be one whole thing. Or maybe that. I might need to clone this repo into VS Code so I can get color matching braces. Let's find the smallest unit of something. Let's go from the end. What's supranum? Oh, that's not defined by us. Oh. What is supranum? Did I spell it wrong? Oh, supremum. Okay, supremum. Outputs the greatest element of a sequence. Okay, so you have an array of things, and it gives you the biggest one. And then we've got sift, and I think sift is going to be the opposite. Oh no, okay. Outputs a new sequence for instances of f removed. Okay. And then when. A boolean and true. If condition is not f, calls the true quotation. Okay, so it's like an if with only one branch. Okay. So let's do this last block, which I think is here. I really don't know where to start reading the second blob. Okay. Do we reckon that's that? So that, there. I don't know. Don't know where the premises end. Let's clone. We're gonna clone. Give me a Ubuntu. Let us have syntax highlighting. My editor has run away to another monitor. Here we go. That's a little bit easier. I don't think I have enough colors. Okay. Oh, yeah, that's fine. This one. Where does this go? Really? Okay. Let's chunk this up. Okay, there we go. I should have done that to start with. Right. So we have edited snakes come into this. This moves and keys, so we're getting the... This moves a function we define in here. No. What is moves? Oh, this is moves. This is the constant we defined for the moves. So we're getting all the keys from the moves. That makes sense. So that'll be getting these. And then we have what's clone? I guess clone is gonna... Oh, is this making... Okay, cool. So this actually I ran into. So with objects, you have the typical like, is it a reference to the object, or is it the object itself, or is it a shallow copy? Is it a deep copy? So this is making a copy of an object. So I'm guessing this is making a copy of... Oh, hang on. What is this being applied to? With. What's with do? Oops. Oh god, okay. Partial application on the left. The following two lines are equivalent. I love this note. This operation is efficient. So it takes a parameter, an object, a quotation, and it applies the parameters to the quotation, and then leaves the object untouched. Okay. So our keys, our quotation, and then width. Our keys, our quotation, and width. And then this in itself is being mapped to all the snakes. But then first we're map filtering. What is map filter? Besides being obviously a combination of map and filter. I don't think we're going to... Oh, it is nothing. Interesting. Do they define map filter? No. Interesting. Okay. So we're checking. First, it's not a Boolean though. So this is getting the head. This function is getting the head. And then we're map filtering that to a bunch of snakes that have been modified in some way. This is a change body. So what are we changing about the body? Tuck first, V plus. What is V plus? Is that a thing? God, it is a thing. So this takes two sequences of numbers and outputs another one. So it adds the U's and V's. So if we've got two sequences of numbers here, this is all running on the keys. Does keys do what I think it does? I have misunderstood. These are not the keys. The keys are the first item. So this is getting moves keys is then producing an array of coordinate pairs. So from here, we're getting an array of 1, 0, 0, 1, etc. Okay. Okay, but these are not actually this is the moves. This isn't actually coordinates. These are the modifiers that need to be applied to each coordinate. So I understand what this is going to be doing. This is going to be applying these moves to all of the modified snakes, and I guess checking whether they exist in those spots is probably what's happening here. Okay. So then what do we think the next bit is doing? So we're getting the body. We're mapping, getting the body to all the snakes. Then we're unioning all. Okay, so this is going to be... If we're unioning all, we're unioning all those sets. So we're combining all the snake arrays into one set. So this is going to produce one set containing all of the body parts. Cool. So we get one set containing all the body parts, and then so I guess this is going to be checking. This is checking whether any of the snakes are in hazard, and if they are, applying the health change. Whether they're in food and applying the health change. So this part is getting the possible moves of all the snakes. I think this is getting any health changes other than just the turn health change. product sequence. A constructor for a product sequence. Isn't this like, I don't know any of these functions, all this stuff in there, I don't know. I'm just able to whack open the docs and just find it immediately. A product sequence. Oh my god, of course there's an inbuilt constructor for the Cartesian product. So yeah, here we're getting the Cartesian product. We're in pure min-max territory. What is harvest? I can't wait for Gifty to eventually make it onto the stream. We did try and make it work today, but technical difficulties, and tell me that I've completely misinterpreted all this code. So, okay, harvest gets rid of all the empty sequences. So we're then getting rid of all the, I guess this is all the snakes that will have died. And then we're producing the Cartesian product. And then collect by. So that's going to be some kind of filtering effect. Applies a quotation to each element in the sequence and returns a hash table of the elements. Oh, that's fascinating. The keys are the keys to the output of the quotation, and the values are the elements that transform to that key. And the values are the element that transform to that key. So you have a function and a list of things, and it produces a hash table where the keys are the results of the things applied to that function, and the values are the original result. That is cool as hell. And that is so useful in so many, like... So, you know, like the typical... you've seen the Brett Victor time-traveling debugger demo? It's for like a... Is it Brett Victor or Brett Victor? I can't remember. Sorry if I've... well, that's Elm's one. But yeah, so anyway, it's like a dev environment where you can have a game running that you're developing, and you can rewind through all of the like changes of state in the game, and like that collect by function would be really cool for building that. Would be really useful for building that kind of thing, or like an undo stacking application. Very cool. And then we're stuff. So this is in the end producing an array of modified snakes where do we actually like make them, like actually make a score from them is what I don't get. But yeah, it's like applying all the possible things that can happen in a turn to an array of snakes. And then we've got nearest, where is nearest food used? Oh, okay, here's the actual move action where this actually like applied. So we score the moves, and then we find our nearest food. Is there A-star pathfinding in this? Yes, yes there is. Wait, is there an A-star? What? There's no way that was a... I thought this meant subtype. Tuple, I want inheritance, tuple subclassing. Yeah, so there is an A-star superclass somewhere. Where does that come from? What's the... Pathfinding. I wonder if that's another Gifty library. Or if that's a inbuilt vocab. Oh no, it's right there. There we go. There's already a vocabulary built into Factor for A-star pathfinding. Very cool. Okay, so they've got an A-star pathfinding, which has an A-star class, so they're subclassing it. Okay, chat. My brain's wrecked. There you go. That is a Factor min-max snake, and I think we got a good way through passing that code. Thank you, Gifty, for sharing it. We will hopefully chat to Gifty at some point, and so we try to make it work today, but technical difficulties. In 90 minutes, we have the Platinum Tournament. It is the finale of the Platinum Tournament. Yesterday we had the quarterfinals, and we've got some great snakes who have gone through. So we're doing the semi-finals and the finals today with our friends over at Twilio, my employer, at the conclusion of the final day of their conference Signal. It will be at twitch.tv/Twilio in 90 minutes. Myself and Eileen will be casting it, so do not miss it. Thank you for tuning in today. Thank you for joining me in more Factor Madness. I believe the next Coding Badly we will be rejoined by Kevin, so we'll probably be moving off of Factor now. I've had my fun with Factor whilst Kevin has been away, but we'll probably pick up something with a little bit more front-end focus again now that Kevin is back. If you have any requests or ideas, feel free to let us know. And otherwise, thank you all for tuning in, and I'll see you in 90 minutes at the Platinum Final. See you soon. Bye.